All right, so here's another situation we might come across today, is coming up with that linear equation from a situation. And this one's a typical bank account situation, is you've started a bank account and you initially deposit $145 in it. So basically on day zero or month zero, you started off with $145. You have decided that in order to save money, you're going to add $80 a month into that account each month. Just 1 month at a time, 80 bucks in, 80 bucks in, 80 bucks in. So what we want to do is we want to write an equation that will track the growth of your account. Okay, so this is a lot different from our last example where we were looking at the graph. But if you think about it, we're still looking for the same two things. We're looking for the slope, or in this case, I think it's better to think of it as the other way we've seen it termed as, which is what's called the rate of change. So rate of change is the same as slope. It's just more the slope's more the visual interpretation of it. Rate of change fits more with this problem. And then of course we're looking at the y-intercept. But another way to think of the y-intercept is just it's our starting point. Where did this problem start from? All right, so let's take a look. It says you start a savings account and deposit $145 in it, which means if I were to graph this, there'd be an initial point at 0, 145. In other words, on month 0, I've decided to start off with $145. So this is our y-intercept. So our starting point is the graph is going to start at $145. Now the rate of change, and well, that's this part. If you've decided to add $80 per month into the account, that's a rate of change. It's like miles per hour or feet per second, except this time it's $80 per month. So we'd write that as $80 per single month. And so even though we didn't pull this from a visual graph, we can still find our slope or rate of change, and we can still find our y-intercept or starting point. Okay, which means our equation, y equals mx plus b, would look like this. Y equals 80 over 1, or if we just want to change it back to the 80, that's fine, times x, because our rate of change or slope always goes next to x. And then our starting point was the initial $145 we put in the bank. And so this would help us keep track of our growth rate of our account. $145 initially invested and $80 times the number of months that have passed gives me a grand total, which would be y. All right, so this is another way we use linear equations in slope-intercept form, is in real-world situations where they give us this information.